Hello and welcome back to another holistic education video. In this video, we are continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. In this video, we're tackling problem number 7, which states, point P is the center of the circle in the figure above. What is the value of X? There's a couple of different ways to find the answer to this problem. So we'll look at two methods below. The first is using the INSCRIBED angle theorem, and the second is using properties of isosceles triangles. We want to figure out the value of this angle X here, but we have this weird shape that's going to be hard to decipher. But the key thing to realize is that we can cut this shape in half with a straight line from point A to the center P, and now we have two identical triangles, which we can then use different triangle theories to conclude the answer to this problem. The inscribed circle theorem states that the angle of a point from the midpoint of a circle covering a certain distance is exactly double to the angle of a point on the circumference of the circle covering the same distance, which means our angle X here is double this angle. So this full angle is 1/2 of X, which means that this part that we've cut in half for our triangle right here is 1/4 of X. So we have an angle right here that's 1/4 of X, and we have an angle here that is 20 degrees, and then we have another angle here, which we will call APB, because it's covering these 3 points. And because these 3 angles make up a triangle, they must add to 180 degrees. So we can say that 1/4 of X plus 20 degrees plus the value of angle APB equals 180 degrees. We can also continue this line from A to P straight through P, and we'll cut this value X in half. So this part right here will be 1/2 of X. And you can see, because angle APB and this 1/2 X angle make up the entirety of one side of a line, they also add up to 180 degrees due to the properties of supplementary angles. So we can say that 1/2 X plus angle APB equals 180 degrees. Now, if we solve this side for angle APB, we get angle APB equals negative 1/2 X plus 180. We can take this value for angle APB right here and plug it back into this equation, and we will get 1/4 X plus 20 plus this value substituted in for APB, negative 1/2 X plus 180 equals 180. Of course, this 180 and 180 can cancel out, and then this 1/4 X and 1/2 X can simplify to negative 1/4 X plus 20 equals 0. We can add 1/4 X to both sides, and we'll end up with 20 equals 1/4 X. Multiply both sides by 4, and we get X equals 80 degrees. So this is one way, using systems of equations of 2 equations, this one for this triangle right here, and this one for this line right here, to get our final answer of 80 degrees. But there's also a second method for solving this equation, and that is using properties of isosceles triangles. So I'll erase all this and we can start again. Once again, the key thing to realize here is that we can draw this line from A to P and cut this weird shape into two identical triangles. But this time, there's a new insight we can look at. We see that every single point coming from this point P out to the edge is equal to the radius of the circle, which means that this line is the same length as this line, which is also the same length of this AP line that we just drew. So here we have an isosceles triangle. And when we have an isosceles triangle, not only are the two side lengths of equal length, but the two corresponding angles are of equal degree as well, which means this is also a 20-degree angle, just like this angle. So now that we have these two angles, it is actually much easier to directly figure out the value of angle APB, because we know that 20 plus 20 plus angle APB equals 180. Because this is a triangle, we can subtract 40 from both sides, because 20 plus 20 equals 40, and we can find out very easily and quickly that angle APB equals 140. And then now, once again, if we draw another line splitting this value of x directly in half in the same direction that we did this AP line, we have this angle here equal to 1/2 x that is part of a supplementary angle pair with this angle APB, which will also add up to 180. And because we know that this angle APB equals 140, it's very easy to plug this in and subtract from both sides to get that 1/2 of x equals 40 degrees. Multiply both sides by 2, x equals 80. So this is an example of two different ways to go about calculating the value of this x angle right here from two different theorems, the inscribed angle theorem and properties of isosceles triangles. And so that's an important thing to keep in mind. Whenever we see a geometry problem like this, there's usually multiple different ways to go about solving it and getting the correct answer. That's the video. Thank you so much for watching. I look forward to seeing you in the next one.